Welcome back to Lean RPA Principles and Practice. This is Chapter 3, Frameworks to Help by Rob King. In Chapters 1 and 2, we looked at why we believe there's a need for Lean RPA and also looked at some of the history to automation and to Lean Six Sigma and the current state of market. Now we're going to look at some of the frameworks to help you introduce Lean and RPA to your customers, stakeholders and clients as we start to look at frameworks to help. Over the course of this chapter, we're going to look at some of the most important frameworks at your disposal for getting started with RPA. In the first section, we'll look at the different types of automation available to you, and setting the right vocabulary for your stakeholders and customers is really important. We'll also look at a technique called runners, repeaters and rogues, which is a terrific method for helping you to define the type of automation that's suitable for your organization. We'll then look at a couple of different methodologies and approaches for being able to implement and drive change within your organization. So, with no further ado, let's start to look at the different types of automation. Just like in the real world, your virtual workforce will come in many shapes and sizes and have many different skills, strengths and weaknesses. Helping you to get started will be creating a common vocabulary for all of your stakeholders and people involved to help them all communicate on the same level with no misunderstandings. One of the biggest challenges that you're going to face in the early days is going to be the misconceptions of what automation can or cannot do and where the best fit may or may not be. Creating a simple framework to help to communicate the differences between the different types of automation is going to be your first step, and that's what we're going to look at first of all in this chapter. I've used this framework many times to help create a common baseline and common understanding between stakeholders and everyone involved within an RPA implementation or pilot. In broad strokes, the types of automation to the left of this chart are simpler than the types of automation to the right of this chart. And it's interesting, when you first talk to people, their impression of what RPA is capable of actually tends to sit more to the right than to the left. And of course, at the beginning of your journey, when you're looking for a pilot, you are probably looking for things that are more simple, that actually are, you can sort of test the technology, you can sort of see how it fits, but you're not going to stress it with the most complicated and difficult scenario that you can think of. So this model helps you to provide a common vocabulary and a common understanding to your customers. So at the left, we've got office automation. Now, arguably office automation isn't a type of automation at all, but actually is really useful as a starting point when you're evaluating what are the options available within your organization. And then moving left to right, you then have desktop automation, which is sometimes also referred to as attended because there's someone involved. Robotic process automation, which is also sometimes referred to as unattended because there's no people necessarily involved. You've then got virtual assistants or chatbots, and they come in many shapes and sizes. So we're going to drill into that one in a little bit more detail. And then finally, at the right-hand side, you've got what's often referred to as artificial intelligence or cognitive or machine learning, sort of the more learning-based type tools. And we're going to look at each of these different types of automation in more detail. Office automation then is an important first stepping stone as you build your automation strategy. The first consideration is to look at your existing systems. In the same way that RPA has continued to develop over the last few years, you also see many mainstream applications have developed automation capabilities. If those capabilities are now available within your core software, then you should look there first to provide the automation solution rather than to look for a third party. Also, both desktop and robotic process automation requires underlying systems to automate upon. Sometimes if your processes are very manual, you need to develop those from scratch. And actually the new breed of technologies such as low-code development environments gives you the opportunity to develop an entire solution to the problem rather than laying on multiple different types of technology. So office automation really is opening the doors to look at what you have or whether you should replace what you have with a completely different solution before you start to consider whether automation is the right tool for you. Also, when we start looking at chatbots and virtual assistants, one of the first questions that we will ask is whether the data you need to train those virtual assistants is available. And sometimes it's not. So developing an application where you can capture that information to be used later on by tools such as virtual agents is an important consideration in your overall strategy. We will also look at some simple solutions that also fit into this category, which provide simple automation, which may be all you need depending on the types of problems that you face. So office automation is our first type of automation. Desktop automation is sometimes referred to as attended automation because it's interactive with end users at the desktop and is typically used to automate repetitive desktop applications that save time, improve accuracy upon processes which you cannot fully automate end to end. Desktop automation provides the facility to create a hybrid working environment of both automation and manual steps completed by a user at their PC. A strong selling point for desktop automation is the ability to mix and match in this manner, with the thinking that it would be more beneficial to automate a few percent of many tasks than 100% of a single process. Desktop automation places the user in control of triggering the automation, which can also stop at key decision points for the user to interact and/or to commit the transaction. Running on the desktop generally allows the user to view the progress of the automation interactively, albeit it's running at a far faster pace than would be possible if the user was entering the information himself or herself. Where the level of confidence in using automation is low, this is a nice step-by-step approach to building up automations in small bite-sized chunks in a way to gain trust and confidence in the principles. From a security perspective, the automation always has the same access rights as the user who triggers it. And by using the application's interface rather than direct access to the underlying database, all validation the user would experience in the manual process would also apply when the automation is running. Some of the automation vendors particularly focus on desktop automation, with the concept being putting a virtual assistant or an assistant, an automation on every person's desktop. Robotic process automation, or unattended automation, is the type of automation that was referred to by the Institute of RPA and AI when they put their definition of robotic process automation together. You may recall their definition is that robotic automation is the application of technology that allows employees to configure computer software or a robot to capture and interact with existing applications, triggering responses and communicating with other digital systems in the same manner as a person. Both desktop automation and robotic process automation rely on interacting with the underlying system solutions to complete processing tasks. In this respect, they differ significantly from virtual assistants and intelligent computing, which are able to replace portions of existing processes with a learning solution. But since RPA actually has no interaction with humans, it's important to understand that the process must digitally be able to be triggered and must be able to interact with the underlying systems with no further human interaction. So it covers all of the tasks that would have been covered by the human, and therefore the end-to-end process typically needs to be automated. For this reason, some vendors provide solutions that allow you to develop solutions at the desktop piece by piece and then move them into an unattended state once the complete process has been automated. Virtual assistants or chatbots potentially could fit at many different points on this scale of left to right of complexity, because there are very simple Q&A type chatbots through to very complex query resolution type chatbots. But we've put them all together under this category of virtual assistants. Virtual assistants allow us to interact using speech or natural language or text, using very natural words that we'd use in normal human interaction. They utilize very natural language processing to deconstruct text or speech in order to understand what is needed for them to carry out and then provide the required response. Simple chatbots can simply provide responses to the types of query they understand. More complex chatbots are able to learn over time using some of the cognitive and intelligent capabilities we'll look at in a minute to be able to learn more solutions and learn more responses. In defining the next and last category, it's perhaps important to put a few definitions in place. Machine learning is the ability for a computer to learn a task rather than simply be given the rules to implement a task. And many times what we see in this category is the ability for a machine to self-learn. There are now a number of different terminologies that you start to see that fall into this category. IBM, who created the Watson tool, is fairly famous for coining the phrase cognitive. Intelligent automation now appears to be the combination of both RPA and machine learning in combination. And the term AI, or artificial intelligence, is the collective term for putting all of these different technologies together. The key to all of the tools that fit here is the ability to process unstructured processes or unstructured data. This differs from the desktop or robotic process automation, which follows a very rigid and strict process and processes data that's in a very structured way, stored in a very structured way. The ability for intelligent automation to take speech, for example, or text messages or email messages and understand the meaning to be able to apply a set of processes is the key to intelligent automation. So let's have a look at some of the vendors and solutions that exist out there for each of the different types of automation. Now, if we were to look back a few years, what you would see is that each vendor or solution would probably have only fitted into one of these categories. And what we're starting to see today is that actually vendors now are crossing into 2 or maybe 3 of the categories that we've discussed. So, looking at office automation, we'll start with perhaps the most famous type of automation out there, which is Excel macros. And it's usually useful to explain automation in terms of Excel macros, as people are familiar with the automation that's possible of copying data between cells and spreadsheets. As a form of end-user computing, Excel macros have been out there providing automation to users for a long time. But there are some more complex types of automation that are possible. Tools out there such as AutoHotkey provide the ability to script small automations or repetitive text that can be sort of just keyed by pressing a function key or initiated by pressing a function key. And this is a very simple type of automation that can sometimes be implemented to provide an initial introduction to what automation is possible. If this, then that is used to trigger different types of applications, and maybe something again that provides simple automations. More commonly known are OCR type tools, which convert analog data, i.e. something on a printed page, into digital data. And that ability to learn writing and handwriting and OCR actually does sometimes cross over into intelligent and cognitive type computing. And then finally, there are third-party software. Mendix is here as just as an example of a solution that actually lets you develop applications very rapidly, and may be better to redevelop the application than provide an extra automation layer across the top. Plus, not included here are all those applications that exist out there that have simply added automation to their existing portfolio. Moving on then to desktop automation. And with over 30 vendors out there, it's difficult to include everyone on this list. So this is just a sample of some of the vendors out there that provide desktop automation. Many organizations that do provide desktop automation started here and have slowly started to develop capabilities to allow them to do unattended, and then develop further capabilities to move into perhaps the more cognitive. Pegasystems is one of those examples, who started life perhaps focused more on the desktop, but allow you to also run the automations unattended. UiPath, NICE, also provide the same type of functionality. Robotic process automation then. Some organizations, such as Blue Prism, have focused very specifically on one area and therefore specialize in robotic process automation. Other service providers provide a spectrum of different services. Virtual assistants then differ from desktop and robotic process automation because they no longer rely on underlying systems being in place. We've all had experiences with Apple's Siri, Amazon's Alexa, or MS Cortana, which understand natural language in a very natural way. Virtual assistants or chatbots, though, can range from the very simple as a Q&A bot, and tools like Microsoft's MS Q&A provide a very simple tool for generating chatbots out of help texts or frequently asked questions. At the other end of the spectrum, though, there are tools like Nuance's Nina or IPsoft's Amelia, which can learn based on an initial set of rules, but then learn to develop based on the interactions with the end user. So let's have a look at some real examples of how we've actually implemented automation in each of these different categories. The first example in Office automation involves AutoHotkey. Now, AutoHotkey is an open source solution that facilitates programmable function keys, which can be reprogrammed to contain standard text for complete emails or complete letters. And we used this in a successful trial in 2016 to be able to use in operations teams. And again, could have been done as a desktop automation, but this tool provided a simpler, leaner response. Our second example is Mendix. Mendix is an example of a low-code development tool that provides a faster pace of development, considering options to replace problematic systems before beginning to automate. And the Claims Portal gave us an opportunity to develop an entire application rather than actually layer on automations on top of existing applications. Moving on to desktop automation, we have Pegasystems. Now, Pegasystems acquired a company called OpenSpan, a provider of both attended and unattended automation. And the pensions new business process involved data being keyed across 7 different applications, both internally hosted and public cloud, browser-based applications. Internal applications also involved Citrix installation and was a variety of different technologies. Each manually completed case exceeded 8 minutes in duration. A simple automation, 3 weeks in development, resulted in a between 20 and 47% reduction in time for each case. It also improved accuracy and eliminated rework, improving customer satisfaction as turnaround times also improved. A second example of desktop automation that we've looked at and piloted is document generation. This is a way to collate information from different sources to present to the end user on screen. 2 typical scenarios are sourcing information from different systems in real time to improve the user response while the user is actually interacting with the customer on the phone, or collating and formatting information from multiple sources before storing it in a PDF for onward transmission. Moving on to robotic process automation. Blue Prism provides unattended option, which effectively operates as a virtual person. A Blue Prism robot was constructed to handle website information requests and returning information back to the customer in real time to operate on a 24/7 basis. The POC was successful in demonstrating the feasibility of creating a self-service solution for customers, which was not possible previously because there was a lack of an API in the existing legacy systems. Moving on to some of the virtual assistants then. M&S Q&A provides the ability to rapidly convert FAQs into documents, and the Wizard Innovation chatbot will answer any questions on the team, the services, and any information on innovation that we have through a very natural language interface. Nuance, meanwhile, is an innovative technology provider that focuses on voice, natural language, and reasoning systems to create a very natural human-computer interface. And the Nuance Broker Bot, which was developed as a pilot, provided 70% of first contact resolution rate. 22% were only referred to a live agent, and contact center calls were dropped by 91%. Finally, in the cognitive space, we did a test with IBM Watson. Using data from an underlying system, we had 4,500 questions of data already in existence that we could use for Watson to learn and evaluate. Unfortunately, the conclusion of the pilot was we actually needed more data, which is a common problem with machine learning and cognitive. It does need huge volumes of data to learn. So I'm going to hand this back over to you and ask you to pause the video for a moment and actually start to think about the following 3 questions. I want you to think about 5 processes with which you are familiar. And for each of the processes, which type of automation do you think might be suitable and why? A process might be suitable for more than one type of automation. And if this is the case, what factors will influence your decision to selecting the approach? And again, if possible, we'd like to sort of see your answers and results shared with us on the social forum on the RPA Academy. Right, over to you. And welcome back. So having created a common vocabulary for all the different types of automation, the next step on your journey is start to think about your customer and, importantly, customer demand. This is one of the most critical building blocks in your lean foundations. So we're first going to look at this from a lean perspective and then see how it applies directly to the needs from an RPA or process or automation perspective. The technique we're going to use is called the 3 R's, and the R's stand for runners, repeaters, and rogues. From a business process perspective, your runners are your most frequent demand and are typically serviced by a dedicated team. Your repeaters occur less often, they have periodic demand, and the way you deal with that can vary from organisation to organisation. A rogue, or sometimes referred to as a stranger, is a sporadic or infrequent demand or an exception, and this is typically dealt with through a team of very technical experts. Now, let's have a look at that in a bit more detail. Runners then, you could describe as your bread and butter. They're high frequency, low variability, and back to our lean house from earlier discussion, they're very standardized. They're given to teams that actually can follow the steps in a process. There's very relatively little knowledge or judgment involved in these processes. Many large organizations find up to 80% of the effort is often spent on runner tasks. Repeater tasks then occur less frequently. Now imagine these could be your month-end processes, your end-of-year processes, tax year end, for example, or they could be seasonal variations that you see. This is a challenge for lean organizations, especially where leveling is important, trying to smooth out processes so you have a consistent standard need over time. But sometimes that's not possible, and seasonal demands, for example, provide a sort of great example of when this can be a challenge. typically organizations have to staff up in a way that allows them to deal with these peaks and troughs. That can be through hiring temps through to maintaining a high level of staff than is necessary during other times of the year. Rogues, on the other hand, they are your technical experts. These are low frequency. They're addressed only as they occur, and they actually rely on knowledge and experience. They're quite the opposite of runners. A great analogy used when describing the difference between runners, repeaters and rogues is perhaps a checkout at a supermarket. All of your goods are on the conveyor belt, and the checkout person is there scanning them. And then suddenly one of the items doesn't scan. Now imagine your checkout person, they are a runner. They're actually sort of following a standard process of scanning each of your items. They don't have the skill to be able to go out through the store and actually locate a replacement item. So what do? They turn on a light and put your item to one side and continue processing the runner items. Meanwhile, another person comes along who is a technical expert. They understand where all the items in the store are located. They pick up your faulty item, your defect item, and go off and find a replacement. All the time they're finding a replacement, the remainder of your items are being scanned through the runner process. Eventually, the technical expert comes back, places your item back on the conveyor belt, and it gets scanned along with all the others. This is a typical sort of process that you'd want to sort of see executed in any business. In a business, you wouldn't want somebody with the lack of technical expertise going off and trying to solve a problem. Neither would you want your technical experts going through very simple task-based processes. You want to organize yourself such that you make the most efficient use of resources. This is a great model also for RPA for 3 reasons. First of all, runners provide a great place to start for robotic process automation. They are often very task-based activities, very rote activities, and high volume. So these are your low-hanging fruit. Your runners give you your first candidate processes. Now, whether they're desktop or RPA doesn't really matter. That's going to be a choice once you sort of drill into the actual processes. But actually, your runners get you started. They are your low-hanging fruit, and they are definitely the sweet spot for robotic process automation. Second, we have repeaters. Now, these are less frequent. And these are difficult to resource because you've either got to keep excessive staff or you've got to keep hiring temporary staff. And of course, automation now gives you a new option which you never had at your disposal before, which is the ability to be able to scale up and scale down very easily to these seasonal or peak demands without the need for holding on to additional staff or without the need for hiring in temps, because you can scale up and scale down or even level your robots in completely different ways that you couldn't do with humans. And then finally, we have our rogues. And these are perhaps more suited to our chatbots or our cognitive and machine learning end. I mean, a little while, not too long ago, we would have said this is outside of the scope of RPA. And it technically is outside of the scope of RPA, but it definitely fits into the machine learning end of the spectrum, into that cognitive end, and gives us now opportunities to link all of the pieces together. So runners, repeaters and rogues is a great way for you to look at your processes and types of processes and then select the right type of solution and identify particularly the runner processes as being the starting point for your next RPA implementation. Now, in a future chapter, we're going to look in much more detail at how you select specific processes, but this at a high level is a great place to start when you start looking at your organization and start dealing with your sort of senior management and stakeholders. So we're going to hand back to you for an exercise. The concept of runners, repeaters and rogues can be useful in many contexts and actually sort of typically help us to create new organizational designs. So we will often build events teams to handle repeater processes, technical expert teams to handle rogue processes, and then different functional teams to handle different runner processes. So our question for you is, can you create some examples from your own organization of where runners, repeaters, and rogues would fit? And the question is, does your organizational design match these types of processes? And if not, is there an advantage or disadvantage to doing this? Okay, time to pause the video and I'll be back in a moment. Welcome back. As always, please feed back the results of your discussions onto the social forum, and we'd love to sort of discuss them further. The topic of this chapter is frameworks to help. And so far we've looked at two frameworks to help you engage your stakeholders. The first one to help them understand the types of automation, the second to start understanding their organizational structure and design to select processes which perhaps would be more suitable for RPA. The next framework is actually sort of one that will discuss how you can actually make the best of the situation that you have. When selecting your first process, it's very important that it has impact. So choosing that first process to answer some of the key technical questions and business questions is important, but it also has to have real value. So long as you select the right process, then actually that will lead to a lot more positive discussion about what has been achieved. And this also gives you the opportunity to showcase activities and help other people understand the art of the possible and eliminate a few myths, and also get them engaged in terms of being part of the long-term organization. This will lead you to building a coalition of engaged enthusiasts. In other words, we've created a model to help you support this called Learn, Deliver, Showcase. This is a fairly common model that people use to be able to build upon initial successes. It's planned to help you teach the skills, deliver a solution, and showcase the results to generate more enthusiasm, to help more learn, deliver, and showcase, etc. So step one in your program will be to learn the skills, raise awareness, and engage the stakeholders. And this is where the first two tools that we spoke about in our toolkit really come into play, because it's important for you to engage the right people and engage the right stakeholders to ensure that you have all of the people involved that you will need. Of course, the next step on your journey will be then to deliver. And delivery and piloting will be a topic of a chapter all by itself. But that delivery, as we've spoken about before, needs to have real impact. And to have real impact, you've got to make sure you've got the right measurement systems in place to be able to demonstrate that impact. Now that's generally one of two things. It's cultural impact, which can be a little intangible, but it's also return on investment are the most common ways of evaluating impact. But also consider customer. Customer is one of the key things we look at from a lean perspective, and the impact on the customer is equally important. Having delivered a solution, it's quite often that especially technologists love to move on to the next thing. Where's the next opportunity? And it's really important as part of that delivery that you also take the step to showcase, communicate, and report out, and use this as a real opportunity to milk as much information as you possibly can out to the wider organization. Showcasing your solution is just as important as the delivery in the early days, because few people will know what automation is, or they will have misconceptions that automation is something to be scared of. So your showcase opportunities are an opportunity for you to communicate, this is what we're doing, this is how we're doing it, and this is what we've achieved in our initial pilot. So the Learn, Deliver, Showcase is a model that sort of is a self-fulfilling prophecy. It helps you to garner engagement, increase engagement, identify the people that you're going to need for the next phase, while also delivering real results. Plan, Do, Check, Act, or PDCA, was made popular by W. Edward Deming. We've mentioned him before. He's often considered as one of the founders of Lean and Six Sigma. The concept of PDCA comes from the scientific method of hypothesis, experiment, evaluation, or plan, do, check. A fundamental principle of the scientific method and PDCA is iteration. Once a hypothesis is confirmed, or not, executing the cycle again will increase knowledge further. This is one of the key concepts again of lean thinking, that iterative approach of learning through each step of change. Whether it's a positive or negative result, you still learn and move on to the next iteration. In a bit more detail then, the plan step. In this step, you establish the objectives and process necessary to deliver the results. And in doing so, you have a clear specification of what you're trying to achieve. In the do step, you implement that process. In the check step, you monitor and evaluate the results against the objectives and expectations. And then finally, in act, you apply actions to the outcome for necessary improvement. This involves reviewing all the steps, plan, do, check, act, and modifying the process to improve before the next iteration. The PDCA cycle can be used to coordinate your continuous improvement efforts. It both emphasizes and demonstrates that improvement programs must start with careful planning, must result in effective action, and must move on again with careful planning in a continuous cycle. The PDCA cycle has been further enhanced, which we'll look at in a moment, within Six Sigma, and that's the DMAIC, Define, Measure, Analyze, Improve, Control framework. PDCA is the methodology most used when we look at lean improvement processes. It takes us from the problem faced to problem solved stage. We repeatedly implement in spirals of knowledge that converge on the ultimate goal, each cycle getting us closer than the previous. The aspiration for lean thinking is to drive for perfection, so you never really achieve that goal. It's a continuous improvement methodology. The approach is based on the belief that our knowledge and skills are always limited, but improve with each iteration. At the start of a lean process review, key information is typically not known, and the PDCA approach provides us with the feedback to justify our hypothesis and increase our knowledge. This collaborative approach works equally well for RPA and automation type implementations. DMAIC comes from the Six Sigma methodology. Unlike continuous improvement with its multiple iterations, DMAIC is typically implemented as a single project implementation with a start, a middle and an end. The steps of DMAIC are first, define, which allow us again to focus on what are the customer values. Here we refer to critical to quality, but very similar to lean, they provide us with the value from a customer perspective. A team charter gives us our goals, objectives, and who's involved. And the process or COPIS provides us with who are the customers, who are the outputs or what are the outputs, what are the process steps, what are the inputs, and who are the suppliers. COPIS is a useful tool when looking down at individual processes, and we'll look at it again in a bit more detail in one of the later chapters. In the measure phase, we collect data. Six Sigma is a much more data-driven approach, and getting and evaluating data is a key part of that process. And we actually understand what is critical quality, what is the data that we need to achieve those performance standards, and what are the performance standards that we're looking for. Step 3 is analyze. And analyze lets us understand how good our process is currently operating at. How close to the goal or the target is it actually achieving? And what are the causes of variation that make it deviate from that goal? Understanding the causes of variation often involves hypothesis testing, testing different criteria to help understand what is driving the variation within the process. Improve is our change step. These are the changes that we're going to put into the process and measure as they are to see how effective they are. Finally, if the improvements are successful, we will move into a control phase where the ongoing monitoring is established to make sure that the process doesn't deviate in the future. In many cases, throughout the improvement phase where you're looking at different options to improve the process, automation becomes a part of the solution. In fact, from a lean perspective, ever since Sakichi Toyoda started with his loom, improvement has often involved some form of automation. A modern variation on PDCA is the methodology defined by Eric Rice in the Lean Startup. He uses the terms learn, build and measure to describe the phases of an iterative approach to driving innovation and change. The principles laid out in Eric Rice's book work really well for RPA and automation, primarily because it uses the concept of a minimum viable product. What's the smallest shippable increment that will deliver a benefit to your customers or to your people? Delivering rapid incremental change through RPA is a great combination when used with this methodology. And the stages are very similar to the ones we've discussed in the previous methodologies. The learn phase is perhaps a little bit more creative in terms of identifying what is value to the customer. The build phase is perhaps a little faster because of the tools used. And the measure phase is very similar in understanding what is the impact being achieved and then feeding that back in to your lessons learned and what you build in the next iteration. Each of the methodologies that we've looked at here are suitable for robotic process automation or similar development projects, and bring to a conclusion this chapter on the topic of frameworks that can help you with your RPA implementation. Before I go though, I'm going to set you some homework and ask you 3 questions to consider before we close this chapter of the course. The first question is going to take us back to the learn, deliver, showcase approach for how you engage your stakeholders and how you communicate to the wider audience. Thinking about learn, deliver, showcase, what are the advantages to doing this approach for your organizations? And the flip side of the same question, what are the greatest barriers you face? With this in mind, how can you adapt learn, deliver, showcase to actually address some of those barriers? And finally, who are your key stakeholders? And what is your influencing strategy to address those stakeholders and get them on side? Okay, pause now. Welcome back. Well, I hope you found that exercise useful, and we'd love to hear what you have to say by posting anything you found or discussed on our forums at RPA Academy Social. In the meantime, thank you for listening. In the next chapter, we will look at the impact on people